It works. Good morning, everyone. My name is Anurag, and I'm with the APNIC44 program committee, and I'll be moderating this session. So this is a session on the technical operations 3, and we have some impressive speakers lining up, talking all the way from DDoS to blockchain and so on. So we'll start with Avishnay Zavoznik from Imperva, and he'll be talking about one of the DDoS, a large DDoS attack which happened last year, and would be sharing some insights around that. Avishnay.
Okay, do you hear me? Yeah. Okay, so hi, I am Avishai, and today we'll talk a bit about the latest denial of service attacks and see how does this have to do with IoT devices, and we'll take the study case of Mirai that was a large denial of service attack that I bet you all know at least by name. I'll present myself. I'm based in Israel, working as leading the DDoS research team in Imperva in Capsula, which provide a WAF solution and DDoS mitigation solutions. Here you have my social links, so feel free to hit me up either there, or I'm staying here for the next few hours, so you can get me there as well. Let's see a bit about you. So just by a show of hands, and I'm going to make it a bit interactive, so feel free to say any questions you have or answer the questions that I ask. So now by a show of hands, raise your hands if you know what DDoS is. Okay, good. And raise your hands if you ever had a hands-on experience with DDoS as a victim. As a service provider? As attackers? No. Okay, great. So the way that we look at DDoS in our research team is rather different than analyzing by setting some honeypots or analyzing by making some reverse engineering of malwares that take part in botnets. The Incapsula solution is based on a private cloud that has above 30 different data centers, which are different points of presence, and the data that flows between the clients and the servers, or in our case of DDoS, the attacking devices and the victims that they are attacking, passes through our systems. So we have a very large network, 150,000 WAF customers, which face layer 7 denial of service attacks, and above 200 BGP networks. And by this, we get a very large-scale understanding of what's going on in that field and what's trending. And this is what I'm going to share with you. So let's start at the beginning. There was nothing, or at least there was no D before the DOS. It was just DOS. And I don't know if you remember in the 90s there was that WinNuke thing in the old versions of Windows, in which one machine could set down one machine, and it was great. And by that time it was just a matter of who has more bandwidth capacity. So if your outbound capacity is larger than the victim's inbound capacity, you won, and that's it. But then things became a bit more complex, and attackers started using some different techniques in which they are abusing some open services that are in the internet to amplify the traffic that they are sending, because obviously one machine against one machine does not scale. So here we're talking about reflection and amplification attacks. Reflection means that the attacker can spoof his own source IP. And when I spoof my source IP and send a request to a certain server that gives some service, the response would be sent to whatever spoofed IP I chose. In this case, it is the victim. Okay, so the source IP is spoofed to be the victims. And by this, the response will arrive at the victim. And the other key factor in this reflection amplification attacks is the amplification one. So some protocols have a response that is way larger in terms of bits per packet than the request. So if, for example, a DNS request is a short UDP message, like between 40 and 60 bytes, I think, the response will be much larger. And by doing this, an attacker that has an outbound capacity of, say, 100 megabits can amplify the effect on the victim of up to 50 times. This is what we call the amplification factor. By 50 times 100 megabits, you get around 5 gigs of traffic with not so much effort. And when we're talking about some different protocols, NTP has an amplification factor that may go up to a few hundreds. And so this was very useful. But as time went by, we started analyzing what trends in the DDoS field, and we see that though the bandwidth of these denial of service attacks is growing, the amplification attacks are decreasing. And this is where you understand that how come? Does anyone have any idea? Come on, it's the title of the presentation. Okay, so there was a new player in this field. There was the IoT attacks. So what happens here is that an attacker takes control over many different devices, and at his command, all these devices can send traffic to a specific victim. And we saw some, this is what we call a botnet, and we saw some botnets that go up to 100,000 devices. This is quite a lot, so you are using the bandwidth capacity of lots of devices. And we saw that many of these massive botnets are IoTs. IoTs stands for Internet of Things devices. Obviously, the definition of IoTs is a bit amorphic or has some wide margins. I call IoT whatever is connected to the internet and has a dumb operating system. Okay, so we see that this, here we have sort of an analysis of a forecast to how our IoTs are going to grow within the next few years. And we see that in the next 5 years, they're going to triplicate. And the reason for this is that how many laptops do you have? How many laptops can a single person have? How many laptops? I have 2. You have 2. You know, it doesn't go much more than this, and we are the tech people. And same with mobiles. But when we're talking about IoTs, so you have your CCTV camera connected to the internet, and you have your smart car that you would like to connect to the internet, and some smart house with a smart fridge or light bulb or whatever. So there are many devices per capita that are connected to the internet, and this is quite making sense. So there are lots of them, and they are going to grow. So this was the first answer to this question, why use IoTs for DDoS? So first, demographic advantage, obvious. But the second, and I like to say that a hacker does not wake up one day and say, what would be the coolest? Let's do it by using cameras or routers for setting out these denial of service attacks. Usually it's a matter of hacking, you know, DDoS is business. And in business, you want to be as effective as possible and to put in the fewest resources to get the highest profit. And by this, we can say that IoTs are the lowest hanging fruit for hackers because they can run code, they are connected to the internet, and they are very poorly secured. When we're talking about Mirai, Mirai was using, in its first evolution, it was using just default passwords over Telnet and SSH, And this is how it spread, and it peaked at tens of thousands of devices, or maybe more. So this is what we're talking about, poorly secured. And there are no antiviruses that I know of for IoTs yet, and they are less frequently monitored, and they are less frequently updated. So this is like the great candidate for becoming a bot, and it actually happens. When we are scanning the recent history, we see that we had Mirai that was the big bang of IoT DDoS attacks. In the 20th of September 2016, it hit the blog of Brian Krebs with a 600 gigabit attack. And then there was the OVH attack, which is a hosting provider that claimed to be attacked by 1 terabit per second. And then the Dyne attack. Raise your hands if you heard about the Dyne attack. Yes. There were quite many people did, and even my mother did. It was the first time that my mother figured out what am I working for, so it was nice. Then the Deutsche Telekom, which was sort of an evolution of the Mirai source code, which was already publicly released. And yeah, I lied to you when I say that Mirai was the first one. In Incapsula, we already saw some IoT botnets attacks before. So back in December 2014, there was an attack of around 40,000 devices, small office and home office routers they were. And then some CCTV cameras that we already analyzed attacking in our research labs in Incapsula. So yes, there are lots of them. And now, obviously, there's going to be much more. And there are already some more. If we'll have time, I'll scan some. I'll talk about some of these. Let's drill into Mirai first. I'd like to cluster the attacks, if it was not clear by now, to volumetric attacks or network layer attacks that are split into two. One is the bandwidth attacks, that is a massive bandwidth clogging the inbound pipes. And the other one is the PPS attacks, which is sometimes overlooked. PPS stands for packets per second. This is also a very important factor when we're talking about DDoS and when we're measuring DDoS. How many packets per second can your router handle? So the high packets per second are usually with small packets. These are the SYN floods and sometimes the ACK flood, which have small packets sent to the victims and making the network devices work hard or consume their CPU and their open connections, etc. Then we have the layer 7 attacks. Layer 7 attacks are not measured neither by bandwidth nor by packets per second, but by, can you guess? Requests per second, okay? So here you will not see anything in terms of routers and of inbound connections, but in requests per second, requests that are going to the, say, HTTP server or to the mail server or whatever server is being attacked. When we're looking at Mirai's source code, we see that Mirai was very nice. They had like, it was very user-friendly. There was CLI. The source code was released publicly. It was very easy to use. And here you can see the different types of attacks that Mirai has to offer. And there is actually a wide range of attacks covering all the different types that I talked about in the previous slide. So I'll go over a few of them. So first, there's the UDP Flood, in which Mirai has to offer two different types of UDP floods. One is the straight up, and the other one is the optimized for speed. Straight up is highly configurable. You can configure almost every parameter in the UDP header and in the IP header. And then there's the optimized for speed, which is less configurable, but its speed is better. It's about 10 times faster than the straight up. UDP is it's a bandwidth attack and not a packets per second attack. And we can tell by the size of the packet, which is quite large for a single packet. Another nice thing that we saw here is that when we looked into the code, the source IP, according to the documentation, can be spoofed. And here we can see it. When you open the manual of Mirai, yes, it has a manual, or at least a help, you see that if you want to spoof the source IP, you have to set this IP, and then the source IP would be randomized. But actually, it never happens. A couple of lines of code later on, this IP is being masked, and you get 255.000. What makes this condition later on never be met. So the source IP is never randomized, and this is a bug that was released in GitHub. I believe that someone fixed it later on, but at least this is the original version of Mirai. So yeah, you can see that there are humans behind it, and humans make mistakes. The other one is DCP Flood. So Mirai has 3 types of DCP floods, SYN, ACK, and another one. The SYN flood is a PPS flood, okay? Many small packets being sent to the victim. And it's highly configurable again. A very nice thing is that you can even configure the TCP flags. So a SYN flood can be not a SYN flood, but maybe you can change the TCP flags to whatever you want. And then the ACK flood, which by the packet size, we can see that, is it a bandwidth or a PPS attack? T-shirt for who says? It's a bandwidth attack, but anyway. What was it? OK. Yes, and the third one is Storm Flood, which is a bit more complex here. There is first a 3-way handshake that is being accomplished between the attacker or the bot and the victim. And once this 3-way handshake is completed, the victim will start sending many push ACK packets, TCP packets, to the victim, which are quite large. They have a large random payload. And the idea here with push ACK is that when you use the additional push, it makes the operating system on the other side not just it flushes every single packet to the operating system, and by this it can also exhaust some CPU resources and not only networks. Any questions by now? OK. Oh, this was a simulation time, but unfortunately, I cannot set a demo here. So maybe we'll simulate the simulation. So let's imagine what's happening here. Let's say if there was a bandwidth attack, here we have a dashboard, and we see that what happens in the router, it's inbound bandwidth and packets per second that it handles, and then the firewall, and how much traffic does it pass or block, and then the outbound traffic. So now we will imagine UDP flood. What would happen here? What would happen is that the router would start receiving more and more bandwidth, and you would see this measurement here going up. The PPS would be affected, but not as much as the bandwidth. And the firewall would start to have start handling some malicious packets, say. If the firewall identifies them, then it might start blocking them, and at first we will not see so much difference in the web server that's behind it, but after a few seconds or maybe minutes, the bandwidth pipes will be clogged, and the firewall will not even receive inbound packets, and obviously the web server will not function, and users will start complaining that they cannot access their servers. Okay, PPS is a bit different. Here we have the router here, and the PPS will start going up until a certain point in which the router cannot handle any more connections, because maybe it opens a session for every scene, or it has to keep something in its memory. And this is when the router would stop passing all these packets to the backend, to the servers, web servers or whatever. And when we're talking about application layer attacks, we will see that here you will not sense anything, because there is not much difference in terms of packets per second or bandwidth, as I said, but the web server will start handling more and more sessions and receive more and more requests, and its CPU will go up until a certain point in which it cannot operate anymore. So this is the difference between them. And this was the simulation of our simulation. I'll go on to HTTP Flood. HTTP Flood is another flood that was supported by Mirai. It is sending many HTTP requests. It can be either a GET or a POST or a HEAD or whatever method you choose. And you can choose the path. And here it even has it supports multi-threading. So you can multi-thread if you can do it on the IoT device. The nice thing about the HTTP Flood is that here you have some more parameters to play with. So it's not pure network. One of them is that the Mirai, according to Mirai's source code, you can see that there are many different user agents. Do you know what user agent is? OK, great. So the bot would randomize its user agent to one of the ones here, which are actually mimicking the behavior of some known browsers. This is sort of a technique to try and bypass some mitigations. For example, if your browser does not accept unknown user agents. And that's it. I'll talk about some more features of Mirai that we saw in the source code. So first, we call it territorial predator. Mirai, once it installs itself on a device, it will search for some other known malwares. And if they were already pre-installed there, it will remove them. Another thing, it's not only this, but Mirai, Mirai spreads itself by accessing through SSH or Telnet on port 22 or 23 to another device. And once it does it, it kills the port from which it infected the machine. And can you try to understand why would it do it? It's like closing the door behind you once you break into a house or something. Are there any ideas for why to do it? Yes?
Would it be possible for someone to write something that would go around and like clean up the infection if the port was still open?
Sorry?
If the port was still open,
Yeah.
can you go to the microphone, please?
Yes, exactly. Yeah, I can repeat what he said. So first, is large fine?
Sure.
Cool. Yeah, so you're right. Actually, you don't want anything to go through this very same port and remove the malware. Another thing is that they would not want to have some infection loops. I mean, if device A infects device B, you don't want device B to infect back device A because it's worthless. So this is another thing. And we saw in some botnets from the very ancient past, we saw that there was some infection loops which did nothing but damage to the device itself, which is not what the Mirai creator was trying to achieve. And another thing is that you don't want any other malware to be installed on the same device because, as we said, DDoS is business, and you don't want any competitors to be around. Here we see some evidence for the fact that Mirai was used as DDoS for hire. There are many different DDoS for hire services, either in the dark web or in the open internet. You can find them. Some of them are even available on Fiverr. And here you see that they are managing their users and their customers. So one could buy a Mirai DDoS for money or Bitcoins or something. So that's it for Mirai. Let's see how much time do we have left to talk about the future. Not much. So we see that since Mirai source was released public, there were many developments in the field of DDoS. So first, the command and control functionality, which is the way that the bot connects to a certain command and control server, changed from like hard-coded IPs to domain generation algorithms and some peer-to-peer in which the bots connect between themselves. We see different spreading techniques that are not only the default passwords that were used by the original Mirai, such as TR69, which is a protocol that some of you might be familiar with. And sometimes we even saw that the media talked about it, that Windows machines were infected to be used as a relay to some IoTs that might be in an inner network. So this was another thing that we saw. And obviously, botnets are not only used for denial of service attacks, but also for Bitcoin mining and to spread spams. And we already saw some routers that are communicating with backdoors to spread spam, etc. And a very nice and recent thing is the IoT vigilantes, is a sort of like people that are spreading their own malwares and closing the door behind them, but not doing anything with the malware, anything malicious. And this is sort of people that are claim to be taking the law to their hands or something. I'm not sure if I believe them or not. So what we should do with this situation? First, I think it's important to let IoT manufacturers know your device is broken, and I don't want to buy a device that is not properly secured, because we do it when we're talking about our laptops, but we are not yet trained to do it when it's about some cameras or web TVs or whatever. Another thing is web service providers, whoever owns an internet site might be a victim to DDoS. The more we protect against DDoS, the less it would be profitable for the attackers. So this is another thing. End users, this is the hard part, but you know, some guy goes to the store and buys an unsecured Linux machine and installs it on the perimeter, making it publicly available. People don't understand what it can go to and where this stuff can lead. So the technical guys that are asked should take care of this and try to educate them more possible. And regulation, usually I'm against regulation as in general, but let's take an example where I live in Israel. We have that like Halloween holiday in which the kids wear costumes, and the government does not let shops sell costumes that are flammable, obviously. And same here. I think that maybe governments or some regulation organizations should take care of not letting these bad devices be solved, or at least have some sort of, ask for some sort of security compliance. Yeah, and to summarize it all, I think we should all be proactive about it the more we can. So that's it for now. Xie, if you have any questions.
All right. I think we can skip the Q&A and
Okay.
you can ask in person as well.
Great.
We're running late on the time. So.
Great. Okay, thank you very much.
So next speaker we have, he's Mohammad Moinur. He's from Bangladesh, and
Okay,
he'll be
you
talking
want
about
to
blockchain, which is trustless system in the world of cryptography. So very, very interesting talk, and we'll look forward to that.
Good morning, good morning, everyone. I'm here to talk about some features of blockchain and how it can change the internet in the future. So the first thing that pops up in our mind when we talk about blockchain or we see the word blockchain is Bitcoin or some other sort of cryptocurrency. But actually, blockchain is much more bigger than what Bitcoin or other cryptocurrencies can do. So for the time being, please keep your mind broad and don't think blockchain just as Bitcoin. So what is blockchain? Blockchain is a distributed database system. It is totally decentralized. It is mainly a list of always growing records. So here we have got some pictures of the difference between centralized, decentralized, and the distributed database. And there is a small picture of how the blockchain grows, like the green block, actually the genesis block or the seed block. Then it starts growing using the black blocks, and we can have some orphan blocks like the purple ones in the picture. So what is actually a blockchain? It is more like a tamper-proof and revision-proof list of databases. It is open, it's permissionless and public. So it's not possible for a single person or a group of people to modify a record. And it's a Byzantine fault tolerant. So here is a picture of some blocks, like what it contains and what it does not contain. Like it always keeps a timestamp, then it keeps a link to the previous hash, and it has got some transaction records like these. So how blockchain works? It's a growing list of records called the blocks, and each block, as said, contains a timestamp and a link to the previous block. It can be managed publicly or autonomously. We can use also peer-to-peer network, or we can use distributed timestamping. It also can be managed privately. How we can use blockchain in different applications. We can use it for recording of events, then we can use it for marketplace, medical records, identity management, transaction processing, documenting provenance, or smart contracts. If you have heard about the term Ethereum cryptocurrency, yep, Ethereum cryptocurrency was born because of the smart contracts cause. Then we can use it for digital products marketing, property records, voting, cloud storage, financial transaction. Financial transaction is only one of the cause. That's the reason we use Bitcoin or other cryptocurrencies. So you can see that we have got so many other reasons to use blockchain for. So if we look at the history of blockchain, it actually started in the early 1990s. In the 1991, there was a Stuart Haber and a Scott Stornato who started working on it. And if you can see, in 1998, Bruce Schneier, who is actually one of the most prominent cryptographic guy in the world, he also worked with blockchains. But actually, it was in 2008 when someone called Satoshi Nakamoto actually created the current blockchain technology. It used some sort of cryptocurrency issues like the Bitcoin. And when someone actually saw that there is some financial profit, then people actually grabbed it and adapted it very much quickly. And in 2014, with the growth of blockchain, we had to go for blockchain 2.0. So now we will see that what is actually internet. Internet is a 30 years old technology based mainly on IP routing and DNS. The primary purpose of it was to share abundance of data across the world. But now it is under mass surveillance and censored by the different government to capitalize political benefits and other benefits. Internet requires DNS information to make full sort of communication along with each other. It is centralized by the so-called root DNS servers secured by DNSSEC or DNS security. Our web trust system is actually broken. It's under the control of around 1,200 or more than that CA or certificate authorities. Most of the HTTPS or secure socket layer is actually weakly configured. It's prone to catastrophe. It's prone to zombie apocalypse and alien invasion, government shutdown, whatever you say. So here I'm actually sharing two quotes from the father of the internet, that is Vinton G. Cerf and Sir Tim Berners-Lee. Vinton G. Cerf sometimes says that we didn't focus on how you could wreck this system intentionally. And Sir Tim Berners-Lee, he said that I invented the web, but here are the three things we need to change to save it. We have actually lost control of our personal data, and it's too easy for misinformation to spread on the web. Political advertising online needs transparency and more understanding. So that's two important quotes from the father of the internet. So let's see what is actually DNS. It's a decentralized database maintained by some root servers, secured implementation by DNSSEC, but still it's hardly implemented by the domain owners. The web anchor of trust is based on the certificate authorities, which are run by some large companies and which are controlled by governments. If you remember, in 2013, Turkey accidentally took over the the certificates of Google.com, and actually it was, although they said that it was done accidentally, but it was for a purpose. So what if we think about DNS in a distributed blockchain? It will go censor-free. It will be distributed and hard to knock down by a single attack or government or any other people. It can be supported by TOR network or I2P, and it will be private. There are already some DNS chain implementation in the world called Namecoin, or it was BitDNS, but I think Namecoin actually forked to so many other applications. Then one is OkTurtle, then Emercoin or EMCDNS, and there is some more I will talk about in the last. Data storage or cloud storage, our privacy is at stake with the major cloud storage providers. All personal information is stored in the clouds, which is accessible by the providers, the law enforcement officers, or the governments with only a warrant or a subpoena. Then we have got ransomware, which can knock down or wipe out all our information in our laptop, desktop, or servers and ask for some ransoms also in Bitcoin or cryptocurrency. There are already two implementations of data storage in a blockchain, which is StoreJ and Sia.take, and there are more applications coming on like these. So how traffic routing works? It always goes through an ISP, which is running a deep packet inspection or DPI. Then we have got national firewall blocking here and there some websites, some applications. Then people can do DNS cache poisoning. Plain traffic is always interceptable, and people who use some kind of proxy servers or caching data, it can be poisoned. The normal internet, it comes with our privacy demolished. So someone might think that I'm daydreaming, but for what if we can implement blockchain in routing? What if we can add some sort of voting capabilities to avoid bad routes? Or we can add some sort of overlay network with path performance computation. Then distributed hash table maintaining a REMI congestion control system to avoid bad paths and look over good paths or look over more available bandwidth paths. What if we can add or remove prefixes from the global routing table or modify it using a DPKI or distributed public key infrastructure? So everyone up here, I think, knows about SDN or software-defined networking. It's a cutting-edge technology. So mostly misconfigured infrastructures by the newbie, uneducated engineers. The API or the programmability is sometimes vulnerable, and the floatable can always be modified remotely, injecting some sort of bad routes or bad flows. So what if we can add or do some floatable in a blockchain? Floatable is maintained in a blockchain. The modification of floatable is authenticated against a KSI or the keyless signature infrastructure or DPKI. Then saving the events of the blockchain to track down to its root. The log readability will be much more easier. The authentication agents, messages, control interfaces, devices, or state of a service can also be saved in the blockchain. IoT or Internet of Things. It's a $1 trillion industry, and thousands of devices, not thousands actually, more than billions of devices will be connected in the next 3 or 4 years, which will interact in between them. But it's going to be the most vulnerable systems from the prying eyes, because no one actually will care for the small devices put in your home or put in your car or put in your refrigerator or whatever it is. So decentralization is required considering the centralized infrastructure. So what if billions of ongoing transactions in the IoT is stored in a blockchain? Rather than centralizing the data storage, we distribute the database along so many people, which will be a single fail-proof network, and we can avoid MITM or the man-in-the-middle attack for these. We can maintain just a single tamper-proof DHT or distributed hash table. Blockchain has already proven its technology with billions of dollars of markets for cryptocurrency or Bitcoin or other cryptocurrencies. So here I'm going to talk about an application called Blockstack. It's a decentralized internet. A couple of applications include identity, storage, and payments with the possibility of decentralized social network, then P2P marketplaces, community-run voting. It has got a couple of layers, like blockchain layer, then the virtual chain layer, discovery layer, storage layer. We could use any sort of a storage, cloud storage, like even we can use our Bunker server, or even we can use some AWS, Rackspace, or Azure, whatever it is. But actually, we can make sure that the data is transmitted and stored with full encryption. Because although some of the providers talk about encrypted storage, but I can remember of an incident from Hashmail. Hashmail is one of the most prominent commercial email service provider who say that they have got encryption all over their network and in their email system, and that's why they actually charge us for their email service. But they also provided unencrypted information to the law agency and government for some of the users. It has been in the mailing lists so many times. So here is a small picture of the block stack architecture. Someone have heard, I think, that about the about the Bitcoin having two forks, like Bitcoin and Bitcoin Cash, due to the size of blockchain transactions. Okay, so it is called segmented witness due to the confusion and detailed information in between two people. The blockchain had to go for a fork. So keeping it in mind, Blockstack was designed with a virtual chain layer, which helps it not to see some sort of fork in the future and make it secure. Like if it is actually a feature of internet, like for the privacy aware people, so that it doesn't have to go for a long downtime like the Bitcoin or Bitcoin Cash faced. So what is actually the end goal of putting internet in the blockchain? A censorship-free internet, freedom of speech, and privacy in the digital age. So thank you, and any questions? Yeah, Jonathan.
I just wonder, the computational resources of using blockchain, don't they prohibit IoT devices with very small CPUs and very small memory resources from participating?
Yeah, blockchain requires the computational resources is much more higher, and compared to small IoT devices. But actually what happens is we are just storing the transactions. We are not storing any other thing like running them in the blockchain. We're just storing all the transaction, all the logs, and all the information, syslogs, everything in the blockchain, rather than doing anything, using the blockchain for other purposes.
Hello, Alain Jean from ICANN, Office of the CTO. Following up on the previous question, you were talking about potentially replacing the entire DNS by a blockchain. Have you made any scalability study on how much memory you will need on servers to have the entire chain, not only of the different domains, but all the changes since the beginning of times, of ownership of those domains and all the changes that could have happened?
Actually, what happens is the database is actually fully distributed, so it's not actually centrally stored in a single place.
So I understand that in Namecoin, for example, they do that on a specific branch of a DNS. But you were talking about potentially replacing, if I understood correctly, the entire DNS system. That's why I'm asking about the scalability of this approach.
Actually, scalability, if we consider with the normal traditional DNS servers, what happens is we are using root servers and we are using Anycast, or we are mirroring the Anycast servers in different places. But let's say considering the Bitcoin or other cryptocurrencies, the full seed database table is actually shared among hundreds of thousands of people. Considering the total number of root servers using all the Anycast servers in the world, I think that the blockchain table, that full hash table, it will be stored in much more places. So it's not easily possible to knock down the entire system. So it is scalable, and to knock down the entire system, hackers or someone else will have to own 51% of the hashing power of the full blockchain table.
Those arguments I understand very well. And I think you're making a very good point there. The question is, how much memory do I need on one server if I need to have the entire chain?
Okay. If you need to, the storage is only the one issue. Like if it's always growing, so like for the last 10 years, the Bitcoin hash table has been growing, and right now it's around 7 GB, 7 or 8 GB around. So only the storage actually matters. And the total hash table, it's not that much memory hungry.
Thank you.
Hello. Hello. Right. Don Sambandaraksa. I'm a reporter at Disruptive Asia, and I think in this context, I'm also doing an MSc in digital currency at the University of Nicosia on blockchain, on Bitcoin technology. A few comments and a question. I think the question. I mean, just to answer the previous questioner's question, the Namecoin blockchain size right now is 5.09 gigabytes for just 3,800 addresses. That's the current situation. So no, it's not particularly efficient, but it works. Two questions. Did you listen? Do you agree with Craig Wright's rant about how they should bring back direct payment to Bitcoin addresses? Payment of Bitcoin to IP addresses as opposed to over the network for sort of public to vendor payments. So that was taken out recently, and it was semi-controversial. Direct IP payments as opposed to payments to a Bitcoin address. And secondly, and the ISPs would love this. I mean, the last barrier to total decentralization is the ISP, obviously. A couple of weeks ago, Samson Mao at Blockstream launched their Blockstream satellite service, which basically now broadcasts, one-way broadcasts the entire Blockstream, Bitcoin Blockstream, so you can have a computer totally offline, create transactions, and then send the transactions on a postcard almost, and therefore bypass the last line of government censorship, which is the ISP. What do you think of that? And is this a resurgence in sort of peer-to-peer and total decentralization, or do you think it's going to be a fad? So just your thoughts, please.
The first question, yep, I have heard about that. So actually, I do agree with the direct IP payments. And one more thing with the last line of the censorship you are talking about. Yep, there will be some sort of resurgence, because actually what we are fighting for, the entire world is against us, against the censorship-free internet and digital privacy. So there will be a lot of resurgence, and there will be a lot of obstacles in this sort of internet structure.
So next, I would invite Jody Pellet. He's going to talk about IPv6 deployment survey, and that's a topic close to my heart as well. We always want to see more IPv6. So, do you want?
Well, I can use that one. If I get the slides, this screen is black. Okay, let me start while they put the slides in my screen. I started, well, my daily job is training people and helping them to do deployment of IPv6. So we do training and consultancy, basically, not just IPv6, but most of my time since a few years ago, we started in '99 is deploying IPv6. And about 2 years ago, I started to get questions from several ISPs in different places about, hey, you are recommending doing this way, but what are actually doing other ISPs? So yeah, I thought, good question. I know what do most of my customers, of course, but not others, okay? So I started making the question basically in the IPv6 working group in RIPE, and I was expecting just a few answers, but actually I got in just a couple of hours 50 answers, and I said, well, I cannot do this way by means of email, so I decided to set up a small survey. I still don't have the slides here. They know? I cannot see very well. Oh, okay. Oh, it's just power off.
No, it's on the system. Sorry.
Let's see. Okay, let's keep going. I will try.
Yeah, I'll work on it.
Yeah. Okay, so I decided to set up a free source, an open source tool which allow me to do the survey. And well, I expected a few hundred responses, but finally I got, in a matter of weeks, over 1,000 responses. So it was quite good. And right now I took the last figures for preparing this presentation today at 3 a.m. And I got, I think it's 1,513 responses. Okay, so I think it's a good view of the way globally, not just in one specific region, because now I have a lot of answers also from APNIC and also from APNIC that I didn't have before, to see how the people is doing. Okay, so I still cannot see the slides, but I am trying to, even I don't see the content, I can look backwards. Yeah. Okay, so basically this is the data I am collecting in this survey. One interesting thing, just to make sure that nobody got a misunderstanding, is that the survey is not intended for cellular phones. The survey includes those ISPs that are providing broadband service through 3G or 4G or whatever, okay, but not cellular phones. So this is very important to take the. Okay, so the first question is, the people responding to the survey, are they actually using IPv4 or IPv6 connectivity to respond to the survey itself? And yeah, well, 31% is actually using IPv6, which is quite good, I think. This means probably they are even responding, if they are ISPs, they are responding from their own IPv6 connectivity, right? So that's quite good. One important thing I didn't mention before is that initially I made the survey in English, then I translated also to Spanish, and a lot of people helped me, which, for example, Japanese, Chinese, Korean, Brazilian, well, Portuguese. So it's easy for everyone to respond to that in their own language, right? If somebody speak another language and want to help with a translation, just contact me and I can add that translation. Okay, so now I have the slides here finally, and of course thanks a lot to the people that contributed to those translations. So one of the things that I need to do with the survey to avoid duplicate responses from the same ISP, or actually to make sure that all the data that I am collecting makes sense, is a lot of manual work. So I use databases like Whois and so on to make sure to match the data and avoid duplications and so on, right? Most of the responses come from ISPs. They are, if they want, they can provide the contact, and if I have additional questions, I may be contacting them by email, but usually I just got a few emails, and most of them I never contacted them because everything was clear, so it was not needed, right? In any case, I am not really disclosing any data, so just publishing data by countries or regions, so there is not any privacy issue over there. So from From the perspective of which regions are responding, well, most of the responses are coming really from RIPE, LACNIC, APNIC, less from MERIN and AFRINIC, but I think it's quite well balanced over the different regions. As I said before, I had initially just 2 or 3 responses from AFRINIC, now it's much better. And from APNIC, I had also fewer responses, but in the last couple of months, I asked it again, and I think Paul Wilson also reminded the people, please help to respond to this, so we got a lot of additional responses. Regarding countries that are responding well, the winner is Brazil, but luckily there are countries from this region now, like Japan, Australia, New Zealand, where it seems that there is more IPv6 deployment that are responding as well. So the winner in this region is clearly Japan, okay? I don't expect you can see this figure, but you will be able to see it later, just to give you an idea about the number of countries that are responding and how many people from each country as well. If I try to do an analysis from the regional country perspective, basically I can see the degree of residential IPv6 deployment in different regions. So I see clearly that in APNIC there are countries like Australia, China, Japan, Malaysia, New Zealand, which are the bigger deployers, and I am missing responses from a couple of countries that I think they should have a lot of deployment, but actually they don't show up very much, which is South Korea and India. So if you are from those regions, probably you can help to propagate the survey and get a better response from those countries. Obviously, in US and Canada. In LACNIC, there are a few countries that show more in the survey, like Brazil, Argentina, Colombia, Guatemala, Paraguay, Peru, and Venezuela, and missing responses, for example, from one of the big countries in that region, which is Mexico. And in RIPE, almost every country is providing responses, so it's quite balanced over there. Again, still missing a few countries in LACNIC and a few countries in AFRINIC. Basically, the less responses we have in terms of region is AFRINIC again. One of the questions I asked in the survey is, what access technology are you using to provide the service with IPv6 to your customers? And clearly, I think it's obvious that newer technologies like FTTH, sometimes DSL, cable are the winners. So as more, let's say, newer technology you have, more chances to get IPv6 service, which is quite normal, because typically means the support in terms of CPE is also more prevalent, let's say. We look at the possible problems tied to specific technologies to deploy IPv6, and the conclusion is there is not. All the technologies today, all the access technologies today can deploy IPv6, so that's good. Another question we do is, already IPv6 is a commercial service in your network, or you are just trying, it's a small test or whatever. And well, 65%, if I see it correctly, yeah, 65% of the people responded that yes, it's a commercial service. So that gives a lot of validity to the analysis, right? To the survey. Most of the people that say it's not commercial, we talked to them, or well, a few of them we talked, or we knew already from other sources, and they are doing trials. So we expect that this number will be changing. One of the things I am doing as well, I didn't mention at the beginning, is that every 3-4 months, I am checking again the new results and comparing how it's performing, how is the difference. And to be honest, I am really surprised that even there is more and more deployment, obviously the questions related to if it's commercial or not, we get more grow in terms of yes to be commercial, but the rest of the questions, more or less, the percentages are the same. So it seems that we are doing the same 2 years ago than now. And that's important in general if we are doing the things well, but it's bad for some things that we are not doing so well, and you will understand that in the next slides. Again, I don't expect you to see these numbers. I have kind of summary here. One of the questions is how you do the numbering of your warm links, and this is related also to my earlier presentation today. And most of the people, 62%, is using for the point-to-point links /64. So confirms that it's not just the best current practices because we believe it's the best way, but in general, the people believe it's the best way. Okay, so 62% is using /64, and we leave the opportunity to the people to respond if they are using something else to say so, and we have examples of people that say /128, /62, so that means also some people is not really understanding the question or not really understanding the technology at all because they provide very strange answers, like a point-to-point which is /32 don't make sense, obviously, right? We also ask if they keep the numbering of the point-to-point links stable, and 37% of the people, they don't keep it stable. This is not really that much important. It's more important the stability or the persistence of the point-to-point of the LAN numbering, but not the point-to-point link. But just we decided to ask for that as well. And when we ask which kind of numbering they use for the point-to-point links, 61% is global unicast addresses, which again, it's in line with the BCOP recommendation. Another interesting thing is if you are using for the point-to-point link /64 from the customer prefix. And interestingly, 31% of the people is doing that. So that's really quite amazing because it surprises what you will expect. I published an internet draft a few years ago trying to explain that this is a very nice way to do, and the people was very critical with me. Hey, you are telling the people how to do too many details and so on. And now they are, even if it's an internet draft and it's expired, they are basically following that advice. So it's nice. I think it's because it's a logical way to do the things. LAN prefix. Well, people do very strange things here. Even we got this very surprising response from one ISP, and I asked them and they confirm they are sharing one /64 among different customers. This is really, really, really broken, right? I can see some heads over there, but this is really bad. So you should not, I said in the previous presentation, you should not give a single /64 for every customer, but even less break it for different customers. So how we are doing in general in terms of regions? Well, despite having done a lot of training in LACNIC and APNIC and trying to help the community to understand about IPv6, curiously, still in these regions, there is a big percentage, 33% of people doing a single /64 to residential customers, which I guess is something that when we do trainings, we need to stress. We need to tell the people why this may be a problem if the people is configuring automatically the networks, which is the default way to do that. Okay? If they do manually, they do whatever they want. But end users don't know about IP, they know about subnetting, so they cannot do manual configuration usually. 35% is using /56, and this tends to be especially in North America and RIPE. But interestingly, 22% is doing /48, and the best of this is that the people that started the earlier deployments, so it means the people that has more experience, is the people that is doing more /48. I think it shows that they may have started with something different, and they decided to move at some point to /48. So it shows that as you win experience, you go to the right way, which is the normal thing, right? So if you have not yet started, or you plan to renumber your network at some point, maybe you need to gain this experience instead of learning by yourself and requiring that renumbering later. Again, more people than what we initially expected is doing persistent addressing, okay? So they keep the same prefixes for customers in general. And it changed a little bit from region to region. You have those, the figures in the previous slide. I am not going to enter into the details. One of the things we ask as well is how you are doing the transition. Are you still providing, as you can expect, IPv4 service, or you do only IPv6? Okay. So basically, I think there were very, very few people doing IPv6 only, which is normal. But in terms of, let me go back one slide. In terms of transition mechanisms, I see here a small change is very few people is doing MAP. A lot of people is doing DS Lite or 6RD, but more and more people is using carrier grade NAT for IPv4, and then global unicast addresses for IPv6, and slowly I can see an uptake on 464XLAT, which is quite interesting, okay? I think that makes sense that in just 3 months there have been 3 or 4 new deployments, and some of them I have been part of that, so I know that very well. It's for real. It's not just a joke. So I really think that's interesting. And again, remember that this is not cellular networks; it's broadband. Okay. Again, different transition technologies in general are not related or correlated to different regions, so that's about the same. And the bad part of it is still a lot of people doing carrier grade NAT, while other technologies like 464XLAT can provide a better user experience and be cheaper and so on. Regarding the stability of the prefix, when you have a stable prefix, you want to have DNS. So we have also some questions about DNS, and while I am not going to again go to the numbers, but it seems that in general, people that is offering DNS reverse services to the customers is the people that also offer persistent prefixes, which makes a lot of sense. So just to finish, I think in general we are doing more or less correct deployment, but still a lot of people looks like see IPv6 as an IPv4 is trying to give to the customer just 1/64 or one IPv4 address or strange things, and this is something that we need to correct. There are still a lot of misunderstandings, and again, I mentioned this in my previous presentation. You need to unlearn IPv4 to do a correct IPv6 deployment. Otherwise, you are wasting your time. And then better go to carrier grade NAT and don't deploy IPv6. That's my recommendation if that's the way you want to go. And just to repeat, more advanced countries seem to get that correctly, maybe because they have more experience. They tried already the broken things, and they are doing now it right. So I expect everyone to take advantage of that knowledge and go faster and better with their deployment following those advices. And that's it. Here is the link for the survey if you have not already filled it. I plan to keep updating this survey every 3 or 4 months, and from time to time do presentation in different regions. So any new data will be always useful. Thank you very much.
Any questions for Jordi?
Perfect timing, I guess.
I have one question. So
Yep.
In your slide 11, you mentioned that somewhere around 65% networks have commercially launched, and 35% not. So what do you exactly mean by that? Does it mean 65% it's available in production, or does
Yes.
it mean they charge you for it as a
No.
special-
It's a production service. I am never asking for if you charge for it in terms of IPv6 or IPv4. I only ask in terms of charge if ISPs charge for persistent prefixes. Like in IPv4, many people charge for fixed IPv4 or static IPv4 address. It's the only question about charge that I am asking. But so 65% means from all the responders, they have a commercial service 65%. Not a trial or not related to if they are charging for it or not. But my guess is that nobody will charge extra for IPv6. That don't make sense. If you plan to do that, maybe
Some
you
of
need
the-
to look for a different business.
I know some of the operators doing that, and
That's not good.
I agree on that. Right, so with this, we mark end of the technical operations session 3, and you can now head out for the lunch.
Thank you very much.